So it's good that we're starting, and you guys need to kind of, whoops, sit and chill, okay? So this is all about polynomial functions, and polynomial functions, if you, they take this form, okay? And so polynomial functions are functions that, like for example, y equal, or f of x equals like 6x to the 5th minus 3x to the 4th plus 2x plus 2x plus 1. That's a polynomial function. All of these things, all this says is that all of the exponents need to be positive integers, okay? And these things are the coefficients, and usually when you arrange a polynomial function, it goes from highest degree down to lowest degree. Yes. So the degree of this polynomial would be degree 5. Yes. Yeah. Okay. So today we're going to talk about specifically about quadratic polynomial functions. Okay. You know what a polynomial is?
Yeah.
No, it's a parrot that doesn't get to eat its lunch.
Polynomial?
I get it.
Okay, so thank you. So today I am recording this for so anyway, a quadratic function is a specific type of polynomial, right? And you guys kind of know about quadratic functions. They make a special shape, right? And this in the book they call this form is called, what do they call it? General quadratic form. General quadratic form. Okay, so this is like QUA, quadratic form. I've always called this standard form. But in this book, they don't call this standard form because they call something else standard form. Okay? So now I am going to have a couple notes that I'm going to talk about, and then teacher notes. Okay? So if you see a teacher yoke, okay? So y equals ax squared plus bx plus c. So a couple things. If a is a number, you probably know this already, but if a is a number greater than 0, then your parabola goes, oh, you know this makes a parabola when you graph them?
Yeah.
Okay. So it makes a parabola that goes up, and if a is a number less than 0, then it goes down, okay, like that. If the absolute value of a is less than 1, meaning the number inside here is like 1/2 or 0.5. Anyone knows what that? Anyone know what that does to the parabola? It makes it get wider. Okay, so it makes it fatter. Okay, so it you call that a horizontal compression, but I just call it wider. Wider, or you can say it gets fat. Like that. Okay.
And at the end of that?
Wider? No, it gets wider.
No, E-H-A-N.
E-H.
Because of fried sauce.
What?
Fried sauce.
Forget about it.
Oh, Sam. If y is a number, if this number is greater than 1, then it gets skinnier, okay? Or it's a, you know that. Don't you know that? Okay. So for example, if you have y equals negative 2x squared plus 5, that's going to compare to the graph of, if I were to just compare that to y equals x squared. So we could do this on a calculator, but if this graph is, let's change colors. If this is a graph of y equals x squared, Okay? Then compared to that, what's y equals negative 2x squared going to look like? Is it going to be right side up or upside down?
Upside down.
Wider and upside down.
Okay, it's not wider. It's going to be skinnier and upside down because this absolute value is bigger than 1, but the a is actually less than 1, right? So it's going to be skinnier and upside down. It's also going to be shifted up 5, right? So this one would look something maybe like this. So if I were to going to graph that, it would look something like that because you can find the y-intercept by plugging in 0 and getting out that. What else do I have to tell you about? What? Never mind. Some properties of y equals x squared. Okay, y equals x squared. Or this is your kind of your parent quadratic function. So if I were going to graph that, again, it's something that looks like this. What was that? It is symmetric about the y-axis, and it's also even. Okay? And even means that if I plug in negative 3 in here, I get out the same thing if I plug in positive 3. And that also means you have symmetry about the y-axis. So this point 3, 9, right? 3, 9 is going to correspond over here to negative 3, positive 9. Okay? And parabolas have symmetry, and they also have an axis of symmetry. Axis of symmetry. This is for any parabola. Axis, not symmetry. Symmetry. Okay? And for y equals ax squared plus bx plus c, axis of symmetry is x equals negative b over 2a. Okay, and we'll find one. We'll do one in a minute. Okay, and so if I want to find the axis of symmetry of a particular parabola, I just plug that in. What's the axis of symmetry of this one? It's just the y-axis. Okay, so for this one, it's just the y-axis. Okay, and then they talk about the domain. Okay, domain of this parabola. Anyone tell me what the domain of y equals x squared? What values can I plug in? All real numbers. So you could write it like this. That means all real numbers. You could write it like this. Negative infinity up to positive infinity. That's another way to write the same thing. We could write this as x is greater than or equal to negative infinity and not equal to, sorry, messed that up. And no equal to just I'll get rid of that. Uh-oh. I've talked for 8 minutes. Wow. Yeah, that's because you guys are interrupting me. Okay? The other thing... what else? For x, y equals x squared. Domain and range. How about the range? What's the range of y equals x squared? For this is all for y.
0.
So the range is 0, including 0, up to infinity. Okay, like this, because this means that 0 is included. It does go through 0. Or you could write it as x is greater than or equal to 0. That's another way you could write the range. Yes? And then the other thing they talk about, which is kind of important, is where is it increasing and decreasing? Increasing and decreasing. So increasing means where is it going uphill? Where is it going uphill?
Right side.
To the right side.
0 to infinity.
Hey, so you would call that 0 to infinity, except in this case you don't include the 0 because right at 0 it's neither increasing nor decreasing. So right at there, going from 0 to infinity, and it's decreasing from negative infinity up until you get to 0. Okay, so that's how you can intervals on which it's increasing, 0 to infinity. In other words, where is it going uphill? And this is where is it going down. And that's important, like when we start talking about polynomial functions, which go up and down, like that. Let's say, where is this function decreasing from here to here? Where is it increasing from here to here? Where is it decreasing again from here to here? And let's say where. So you need to be aware of what they mean when they say where is the function increasing and decreasing. Okay. Couple more things. Do you guys know how to find for any parabola, for any parabola of the form, this form, then x-intercepts? Do you guys know how to find the x-intercepts? What's y going to be on the x-intercepts? So to find the x-intercepts, you set y equal to 0 and solve for x. Sometimes that involves factoring. Okay. To find the y-intercepts, what do I do? Okay. Set x equal to 0. Okay. Set x to 0 and solve for y. That's kind of easier, right? Because a lot of times you could have two x-intercepts and you always only have one y-intercept. All right. Done with that? Can I move on? Okay, so now we're going to look at the next slide. Where's the next slide? Teacher notes. Those are my teacher notes. So the vertex of any parabola, right? Can I write it on top of this? I think I can. The vertex of any parabola can be found using this form. We'll talk about it if it's in vertex form, how we find it too. But negative b over 2a, comma, f of negative b over 2a. So what that means is find the vertex of this. So this is A, this is B, this is C. Am I in the way? A, B, and C. So the vertex is going to be at x equals negative 4, right? Negative 4 over 2 times negative 2. With me there? Which is equal to what?
What's the f 4 over 4?
We're going to talk about that in a minute, okay? What's negative 4 divided by 2 times negative 2? Negative 1, okay? So that is the x-intercept. That's the x-coordinate of your vertex. This says to find the y-coordinate, I need to take this and plug it into the function, okay? I'm going to take negative 1, plug it in there. I'm going to be very careful with my order of operations, because when I do that, I get negative 2 times negative 1 squared, right? You have to square this first and then multiply it. A lot of people get that wrong. 4 times negative 1 plus 1. And if you do the math, you square this first, it becomes positive 1 times negative 2 makes negative 2 plus 4 plus 1 gives you 3. So the coordinates of the vertex are negative 1, comma 3. Questions about that? Yes, sir.
Yeah. What was the first question you did? And why? It's stuff in red.
Negative b over 2a, right? So this is the general form of the... yeah, so negative b over 2a also gives you the x-coordinate of the vertex, but it also gives you what you plug into the function to get the y-coordinate, right?
Okay.
Because if I'm going to sketch this parabola now, I'm just going to sketch it. That's not a very good sketch. But I know that it goes through negative 1 and up 3. 1, 2, 3. Is this a positive? Is it upside down or right side up?
Upside down.
Upside down or right side up? Okay. Why don't you take your headphone out of your ear, okay, and close your computer, okay, and pay attention, all right? Is this parabola case going to be upside down or right side up?
Upside down.
That was Justin who said that. Yes, it's upside down. Okay? So, and then what if I want to find the y-intercept? What is the y-intercept?
3.
No. How do I find the y-intercept? Look at your notes from the previous problem.
4.
0, comma what?
Negative infinity.
Come on. What?
One.
How do I find the y-intercept?
1.
Okay. Y-intercept set x equal to 0. And solve for what? Solve for y. Shouldn't say solve for x. Okay. So going back, I plug in 0. What do I get out? 1. So there's a point on here, 0, 1. I know it's an upside down parabola, so it's going to look something like this over here. And using the axis of symmetry, right? That's a perfect, no, let's try that again. Let's try that again, okay? Using the axis of symmetry, oops.
How do you know it's starting from like the left
Here comes my axis of symmetry. Axis of symmetry, woo!
Oh, you're cheating.
Okay? There's my axis of symmetry. I can use symmetry to sketch the other half of my parabola, kind of going down like
Did
this.
you read it?
What?
How do you know the like where it starts from is on the left side, not like on the
Because the coordinates of the vertex are at -1, comma 2.
Oh, okay.
Okay? So you should be able to do that. Right? Question? What's wrong, Matt?
Does C always equal the y-intercept?
Does C always equal the y-intercept?
Because if you said everything.
If it's in this form, yes, but not if it's in vertex form, which we're going to talk about next, okay? So vertex form is the next thing, okay? So vertex form, I used to always call this, they call this standard form, okay? So standard form looks like this, y equals, the other one is called general form. I always call this one vertex form.
So what should we call them?
You should call it, I like to call it vertex form, because this tells you where the vertex is. Okay? But just so you know what they're talking about in the book, when they talk about standard form, they're talking about this. Okay? The graph F is the parabola whose axis is the vertical line. X equals h. Okay? And meaning the axis of symmetry is what they mean. Axis of symmetry. Okay? And his vertex is at h, comma k. And when a is greater than 0, it goes up. And when a is less than 0, it opens down. Find the standard form of the equation that has this blah 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 passes through the point 6. So to do this, you just first what I would do is take this 1, -2 and plug it in for h, comma k. So I'm going to do that now. I'm going to not write in red anymore. Yeah, if I were to do that, I get f of x is equal to a times x. H is 1, right? X minus 1 squared. And k is -2, so minus 2. Everyone see what I did there? Now I have to find a. How do I find a if I know a point?
You know a point?
I know a point.
Plug it in.
Yeah, so now I can take this point here and I could plug it in for x and y, right? So 6 is the same as y and 3 is x.
Yeah.
So I'm going to do that and solve for a. So if I were doing that, I get 6 equals a times 3 goes in for x, 3 minus 1 squared, minus 2, which gives me 6 equals 4a minus 2, 4a equals 8, a equals 2. Right?
Yeah.
So now I could rewrite this parabola as y equals, or f of x equals, 2 x minus 1 squared minus 2. And that would be, is that your final answer? Yes. Okay, am I going too fast?
Say it.
Oh, come on, we gotta get through it. We gotta get serious here, okay? Let's go on to the next thing, okay? I don't know. Grab by hand, put the equation into tense. So this you better pay attention to because this is called completing the square, okay? So what you're trying, and people have trouble with completing the square. It's not super difficult. But basically you're trying to get this into the form y equals a times x minus h squared plus k. Okay, so you're trying to change this into this form so you can easily locate the vertex. Okay? So the steps for completing the square, I'm just going to do the steps, so I'm not going to write them down. But what you do, and hopefully you'll figure out why I do this as I go. What you do is you take this, first part you take, if this is x squared, you write x right there. You take the square root of the x goes there, and then half of whatever this is goes here. Have some of you done completing the square before? Okay. You square this, and then you're going to put something plus or minus something here, and then your minus 5 is going to go over here. Because what I basically did, I rewrote x squared minus 4x as this. Because if I FOILed out x minus 2 times x minus 2, what do I get if I FOIL that out? X squared minus 4x what? Plus 4. So do you see how I have x squared minus 4x here? But I don't have that plus 4 up here. So what do I need to do over here to get rid of this plus 4 to keep my equation in balance?
Minus 4.
You take away 4. Okay? So you take away 4 from here. Okay? And then, so in that case, we'll see in a second a case in which you don't subtract, you add. But x minus 2 squared, I basically added 4 to this equation, right, by rewriting it as this. So now I have to take away that 4, so now I rewrite this as y equals x minus 2 squared minus 9, right? Which tells you that your vertex is at 2 comma negative 9. Can you follow that? That's called completing the square. What if let me just do another one. What if I had y equals, I don't know, x squared minus, let's say plus 36, or I wrote 30, plus 6x plus 2, okay? How would I rewrite that? X plus 3 squared. How much have I added to my equation? 9, so I need to take away that 9 plus 2. So this is x plus 3 squared minus 7. Do you follow what I did? Okay. So I'm adding when I rewrite my equation as this, I'm adding something. So I can't just add something to one side of my equation, so I need to take it back away to keep my equation the same, right? And so that's called completing the square. Completing the square.
Let's do separate equations of
What? This is how you complete the square, okay? This is completing the square. That's an example of completing the square. Okay? We're going to do another one where it gets a little trickier. And then that'll be the next to last problem. What if I see something like this? Uh-oh. 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 Let's see if can I move this? Uh-oh. What is the minimum? Oh, I went back too far. Okay. So if you see one like this, which you will, possibly, what you have to do first before you complete the square is take this negative 2 out of it. So your work becomes easier. So I'm going to rewrite this as f of x is equal to negative 2 times, I'm factoring in negative 2 to make this x squared plus 4x plus 1. You get it?
Why would it still be
Plus 2x, you're right. I meant plus 2x. Okay? Plus 2x. So I haven't done any completing the square yet.
Why did it come to,
Because I factor in a minus 2, because it's easier to complete the square when you're just working with the stuff in parentheses. Now, I do the completing the square on this part. So x plus what? Half of this. 1 quantity squared plus or minus something plus 1. Right? What have I done to this equation when I've rewritten it like this? What have I done? What have I added or subtracted? I've added negative 2, because if I square this, I get, so if I FOIL this out, I get x squared plus 2x plus 1 times negative 2, right? So, right, if I, just to show you, right, this is negative 2 times x squared plus 2x plus 1, which is negative 2x squared minus 4x minus 2. So I have actually subtracted 2 from this equation. So to keep the equation in balance, what do I need to do? I need to add 2. I need to add two green ones. I need to add 2 green ones to them. Okay? And when I do that, I get f of x equals negative 2 times x plus 1 squared. 2 plus 1 makes 3. Okay? Do you follow that?
Yeah.
That's the trickiest thing. Okay? When you have a coefficient that's not 1, you have to pull it out front and then do it. Okay? So you'll get the hang of it. Oh yeah, I want to get through the rest. So, how's the fire? Oh, sorry. Let's move on. Still burning.
There's a fire.
No. Okay. We'll open up the blinds after we get to the next one. Okay? Next thing just says that, where's my notes? Okay? All this says, this is really easy. If this, if you have an a squared parabola where a is a number bigger than 0, for instance, if it's positive, y equals 3x squared minus 2, then when you find, all this says is when you find the vertex, you have found a minimum of your parabola, okay? And this says, when you find, this says if a is a negative number, y equals negative 3x squared plus 7 or something like this. When you found the vertex of this parabola, you have found a maximum. Okay, that's all that says. Okay? So, negative b over 2a is the x value where you will find your maximum. Okay? Negative b over 2a is the x value where you find your minimum. Okay? Right? This is a minimum, that's how the maximum. That's important too when you get to calculus, because like the derivative can tell you where this is called a critical value, but it can't tell you whether you're at a minimum or a maximum, so you need to do some algebra for that. What's the minimum value of this parabola right here? Where's the vertex? Where's the vertex? Where's the vertex of this parabola? Four, 5. Okay? What is the minimum value? What's the minimum value?
4, 5.
It's not 4, 5. This is the minimum value. Okay? If I graph this parabola, the vertex is at 4, 5. The minimum value is the y value. Okay? So when they're talking about the minimum value, this is the x coordinate where you find the minimum value. The minimum value is 5. Okay? Because a lot of times, will you put your phones away? Put your phones away. Phones away. Computers away. Phones, toys. Yeah, I don't care. You're supposed to do all that? Okay, you can play with your computer. He's like 3 minutes. Okay. So, how does that apply to anything? Okay? that applies to this, okay? Baseball, you like baseball, right? You like baseball. You like baseball, right, Chase? Yeah. See, Chase likes baseball. So baseball is hit at a point 3 feet above the ground with a velocity of 100 feet per second, angle of 45 degrees. When we get to the parametric equation chapters, we'll worry about this 45 degrees and this 100 feet per second and where this equation comes from, okay? But for right now, we're just worried about that this makes what kind of shape? Upside down or right side up parabola?
Upside down.
Okay, if I plug in 0 in here, what do I get out? 3. So this makes a parabolic arc. It's upside down, which starts at 0, 3, and it kind of goes up, and then it goes down. Like if you hit a baseball at a 45-degree angle, that's what it would look like, right? Okay. So you want to find where f of x is the height of the baseball. What is the maximum height? So you're trying to find the y value right here. So most of you know how to do that with your calculators, okay? But algebraically, you're going to do negative b over 2a to find the x value, okay? So in this case, it's going to be what? Negative 1 over 2 times negative 0.0032, right? Which is negative 1 over, the same as positive 1 over 0.0064. Can someone do that on their calculator really quick? 1 divided by 0.0064. How about you, Kelly? Equals 156.25, right? 156.25. So this x value is 156.25. Have I answered the question?
No, you need the y.
I need the y value. So I need to take this and plug it in and figure out how high that baseball goes. Okay? Because that's the maximum value, not the 156.25. Okay? And I'm assuming you can do that. All right? So, I'm done, and that's your homework, and we're gonna stop. Okay? So, how do I stop this? Well,
Go back to the homework.
I will, but I can't find my. Oh, there's my thread.
I'm gonna get wrong. It was like 10 minutes. Whoa.
How do I stop every search? I'm just trying to get my thing to stop. Where is it? Oh, here it is. Sorry, I'll fix it. Don't worry. Pause.